Alright guys, today we're going to talk about simplifying algebraic expressions. What does algebraic mean? You're going to be using variables for unknowns. What does expressions mean? It means you're capturing something with numbers and letters, so that's algebraic. Just like our faces capture feelings and thoughts, numbers, this right here captures something with numbers and letters and operations. And simplifying means you're going to move it towards its simplest form, which really means you want to combine all of the variables and all the constants. What are those words? Well, let's go over that again. Here you have this little diagram of this expression. All numbers that are by themselves are constants. See, this number isn't by itself, it's being multiplied by x. So all numbers are constants. If I actually had another plus 2 in here, that would be a constant as well. Why is it called that? Because 2 is always 2. 12 is always 12. It's very clear what it is. Whereas your variables, right, that's an unknown. In fact, here's my next definition or vocabulary. Like terms means, see these x's? Because they're x's, they're considered like or alike. These are like terms because they're constants. These are like terms. And this 4 being multiplied, this number being multiplied by the x, that's called a coefficient. Co meaning together, a collaborative, cooperative. And in fact, here are some other examples of coefficients. -4, 8, 11, 7. Those are examples of other coefficients. Alright, so that's the vocabulary we're going to be using. Let's move on to simplest form. So let's pretend we have -4x plus 12 plus x plus 2. Here we have, immediately you know it's not simplest form because why? All the x's aren't together. All the 12's aren't together. And in your homework it's going to ask you to identify parts of this expression. So you would put the constants under constants, right? This is your coefficient, so you might put it, you would write it with coefficient. Like terms, your x's are like terms. So this is the vocabulary that refers to them. But when we move to simplifying, we move towards combining your like terms. And so what I'm going to ask you to do is this. Whenever you go to simplify long terms like this, you need to circle it with the operation. Okay? And you might be saying to yourself, why? The reason is that a lot of you guys are mistaking, you're making mistakes when you go to combine these. For instance, let's combine these two. Here we have a -4x and a positive x. That's -3x. Here we have a 12 and a 2. And that wasn't too hard. Yeah, so we have -3x plus 14. Alright? And we practice doing circling the term with its operation. And you're going to see why in a minute. And so now I moved it to the simplest form. Alright, let's look at another one. Let's do 9y minus 4 minus 11y plus 7. Now a lot of you, so let's circle it with the operation. See that? See what I'm doing? And now I can actually look at this as 9y, -4, -11y plus 7. And a lot of you might be saying, well, that's subtract 4. Well, guys, look at the number line. Here's 0. Here's -4. -4 is right here. So if I look at it as -4, it's right there. If I look at it as subtract 4, okay, we'll start at 0. 1, 2, 3, 4. You end up at the same place. It's the same thing. But the sooner you can look at subtraction as negatives, it's going to really, really help. So let's combine our like terms. 9y and the -11y. That gives you -2y. -4 and 7. That gives you +3. I just combined my like terms. But do you see how much easier this allows you to process something that can be confusing, visually confusing? And I think that's part of the reason why we had so much trouble today, because there was a lot of trouble today. Let's try in class with this. 3x plus 2 subtract 10, subtract 3x. All right, so first step, what? Circle it with the operation. Here we go. See that? I'm circling with the operation. Where are my like terms? The x's. The constants. Where are my coefficients? 3, negative 3. All right, so let's combine them. And we want to put our terms with variables first. So what's 3x and negative 3x? 0. What's 2 and negative 10? Negative 8. I just moved it to its simplest form. I combined all my like terms. All right, guys, do not neglect to circle with operations. All right, try this one. How about 4z minus z plus 10 plus z minus 12? All right, where are your like terms? My z's, my constants. Where are my coefficients? Just one. That's the 4. All right, so now I'm going to circle it with the operation. See that? Here are my z's. 4z minus z plus z. Well, that's a negative pair, so all I have left is 4z. 10, take away 12, that's minus 2. Simplest form. Why? Because I combined all like terms. Okay, next one. How about 6 minus 3n plus 10n minus 11? All right, like terms, n's, constants, coefficients, 3 and 10. All right. Circle it with the operation. Now we're going to combine them. Negative, so remember we want to have our variable first. Negative 3n and 10n, 7n. 6 and negative 11, negative 5. See that? And here's where, this is why I keep pushing that you be good or confident with your integers, because this, what I just did should be natural, and a lot of you guys are still struggling with what is 6 take away 11, or 6 and negative 11. All right, one more. 2g minus 3 plus 11 minus 8g. All right, like terms, coefficients, the 2 and the negative 8. Circle with the operation. So 2g and negative 8g, negative 6g. 11 and negative 3, positive 8. Negative 6g plus 8. So let's turn to page 390. How are we doing on here? We're doing pretty good. 390. All right, it says 5n minus 2n plus 3 plus n. And it asks you to identify terms. Identify the terms, like terms. What else? Coefficient and constant. See that? They want you to identify them here, so what you should do is just take it apart. Like terms, well, 5n and n. In fact, I'm going to circle them so I can see it more clearly. And guys, yes, you do need to write out the word. It helps you learn it. What else? Blah, 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 and 3. Oh, wait a second. 5n and 2n. Coefficients. 5 and negative 2, right? That's being constants. 3. Actually, I guess 3 isn't the like term. It's all by itself. So the like terms were those. All right. Nice. If I had another if I had a 5 here, then I would put 3 and 5. All right, let's try another one. So remember, we are on page 390, so you might as well just turn there and make it a lot easier. 390. And now number 2 looks like this. 4p minus 7 plus 6p plus 10. I think I got that right. So make it in simplest form, but first I'm going to identify my terms. Oh. So, all right, remember, circle it with, see that? Circle with this operation. That's kind of ugly, isn't it? Let's make that prettier. Like terms, all right, well I have a 4p and a 6p, and I have those constants, coefficients, 4 and 6, constants, whoa, those aren't coefficients, yeah, constants, negative 7 and 10. And then if I went to add it, simplify it, combine my p's, 10p, because I want my variables first, 7 and 10 and negative 7, 3. There it is. See that? Guys, and on the last, so guys, I do want you to write out the vocabulary word. I do want you to circle your terms, right, with the operation. It makes everything a lot simpler. So that, let's talk about today a little bit, because you guys were looking at stuff like this. Negative 3 times 2x minus 9 plus 4. See, you guys have all the mathematics to do this. You have all, in fact, we'll make this a 4x. What is it saying to do? It's saying to combine what's in the parentheses. I can't, so I'm going to use distribution. So I have negative 6x plus 27. Do I multiply times that? No, it's just adding it. So now I just add 4x. And then from here, you really want to circle your term with the operation, right? What's negative 6x and 4x? Negative 2x plus 20. If kids would have been doing that today, it would have been a cinch. It would have been a cinchy cake. All right. Let's see here. I think we are almost down to the end. Let's do this. Let me just give you a few more. All right. Negative 3 times 2t, plus 8 minus 3t plus 2. Simplify it, because are all the terms combined? Are all the like terms? No. So let's do this. All right. Well, okay, parentheses come first, right? In order of operations, PIM does. Can I add those? No. So then I'm going to distribute. So I get negative 6t minus 24. I do not multiply times that. I multiply here. Negative 9t. Oh, look at that. I said it and then I did it. And then I'm going to bring this down. 3t plus 2. I distributed here, not here. All right. Now this is confusing, so that's why I circle. And for those of you who like color, maybe use different colors. So, like terms, coefficients. All right. Negative 6t, negative 3t. That's negative 9t. Negative 24 and 2, negative 22. And you see what I did? Distributed. Did not distribute over here because it doesn't say to do that. Combined like terms. And by circling them, I can see very clearly if they're positive or negative. All right. Let's try another one. Here's a mistake that kids make. 8 plus 2 times 6x minus 11 plus 2x plus 3. So guys, don't forget your order of operations. PIM does, right? What comes first, my parentheses